versus Michigan State Part 2, we're going to be discussing the two-sample t-test. All right, if you could turn to your packet in Michigan versus Michigan State Part 2. In this particular lesson, we are talking about the points that were scored per basketball game in Michigan and Michigan State. So you see that we have a random sample of 30 games. So that 30 is going to be Michigan State. So I'm going to call Michigan 1 and Michigan State 2. So that's my N1. N is the size of my sample. The mean is 77.9 for Michigan State. So I'm going to call that X bar 1. And then standard deviation is 11.1. So we're going to call that SX1. And then you're going to do the same thing except for Michigan State. We have 33, and that's N2. We have a mean of 75.6, and that is X bar 2. And we have standard deviation of 5.2, which is SX2. Okay, so first of all, fill out, of course, the pertinent information that we just had, and then the difference is just going to be 77.9 minus 75.6, which is the 2.3. All right, so when we do our hypothesis, remember, we're still going to be doing our phantoms. The phantoms is parameter. And then my parameter, you can either go mu1 is equal to the mean number of points of Michigan, and then you could say mu2 is the mean number of points of Michigan State. Or you could do what I did here and go mean 1 minus mean 2 is the true difference in mean number of points of Michigan minus Michigan State. The statistic that I have is the actual data that we have per the game, and that was the x1 minus x2 equals 2.3. The significance level is 0.05, and that was given here. The evidence that we have is our statistic, and we're seeing is that since this is saying, is there a difference? That's my difference. We can see that since 2.3 is not equal to 0, we do have some evidence. Now, here's the key. We know we have evidence. We understand that 2.3 is not equal to 0. We're just saying, is it a statistical significance? And if we get a low p-value, we're saying, yep, it is, but we're going to check that out. All right, so my hoe is always that we're going to assume that there's no difference. This means there's no difference in the number of points scored. This one, there is a difference in the number of points scored. And it shows you two different ways. You can do it the way it is in the blue, or you can do it the way it is in the red. Okay, so we have our P, our H in our phantoms. Our A is our assumptions and conditions. And remember, our assumptions and conditions is we're checking two things, random sample and large and normal, and which is large sample. It does say in our startup that I do have a random sample of 30 Michigan and 33 Michigan State games. It also says that I have a large sample of 30 and 33. And remember, if N is bigger than 30, then that is a guarantee that I have approximately normal model. And if I have approximately normal model, I am allowed to go ahead and continue doing the test. If I don't have a normal model, it won't apply to this test that I'm about to do. So if it's not bigger than 30, I have to check it and see. I have to check and see the graph. However, it's bigger than 30, so I don't have to worry about it. So PHAN, name the procedure, and this is called a two-sample t-test. And then we're going to go ahead and run the t-test, and the way we're going to do that is I'm going to go to, you can go to the applet here, but on our calculator I've taught you how to do menu, stat, test, and you're going to do a two-sample t-test. All right, and we are going to put this data in that I have circled at the very top. So that's what we're going to start with. All right, so let me go ahead and jump to that screen. All right, go to your calculator, please. And on the calculator, remember, we're going to open up calculator page. We're going to go to menu, stat, test, two-sample t-test, which is right here. And I don't have data, I have stats. Data is when I have a list that I've put into the calculator. And I'm going to go ahead and put this on here. So I have 30 Michigan State. My S was 11.1. Oh, sorry, that's not 30. That's the average, which is 77.9. N1 was 30. X2 bar was 75.6. And S2 was 5.2. And N2 is 33. And it is a not equal to because it says difference. And we're always going to keep no pooled. And here's all my data that I have, which is T is 1.03 and p-value is 0.30. So you can see as I come down here, that's exactly what I got, my test statistic. And you see the p-value, that is this and this added together. So this side is really 0.153. This side's 0.153, but added together is 0.306. So PHA, N, and then T was your test statistic. O is obtain your p-value. M is make a decision. We're going to make a decision based on my HA and my HO. And we fail to reject HO because, you have to state this, because this is greater than 0.05, you fail to reject HO. So this would be like on the test, this would be how I would count the points. And then we're going to state the conclusion. And so we're talking about HA. We do not have evidence of difference, and this is just HA. So you either can go with HO or HA. And because I can't reject HO, I can't go with HA. So I have to stay with HO. All right, so let's look here. You can see on my hypothesis, this HO is always equal to. The HA has a choice of greater than, less than, or not equal to. When you use the applet or the calculator, remember the calculator is menu, stats, test, and it's a 2-sample t-test. On your parameter here, you're going to have, remember, you have for phantoms, P, H, A, N, T, O, obtain the p-value, M, make a decision, and state the conclusion and context, and that's your phantoms. If you already have this written down, you don't have to write it down again. It's all your choice. Okay, so for this one here, you're going to do the same thing. You would put this is going to be N1. This would be N1. This would be X bar 1. This is S1. This is N2. This is X bar 2, and this is S2. Let's read through this and see how we would do it. All right, when we read through it, go ahead and see. You see that it says, does the data provide convincing evidence that subjects like these who are given a large portion consume more food? So I want the large portion to be more than the small. Well, if you notice, we have the large as, so this will be my mu2, mu1, right? So the large is mu2 greater than small, mu1. In your calculator, however, it always says mu1 and mu2 like this for the HA. So I have to do it like this. So even that large is bigger than small means small is smaller than large, okay? So my HO is that they're the same. My HA is that the large is bigger than the small. And then, so that's my, and then my P, where I'm defining them, the true mean amount of food in grams of large, and then you could say the small is the true mean amount of food in small, or again, you could do this, of course, mu large minus mu small, or mu1 minus mu2 is the true difference. And you could write out exactly what I did up here, and then make sure you put large minus small. The evidence do have some evidence, because it's this right here, 72 minus, or excuse me, that's not the standard deviation. I messed that up. Apologize. It's this one here is your evidence. And that's the evidence here, right there. All right. And this is a PHA. A is here. A is assumptions and conditions. Remember, it's random. It does say it's from 2 random size, and both samples, 37 and 38, both bigger than 30, so we're set. Using technology, so on using technology, you're going to go to menu, stats, test, 2-sample t-test, just like I showed earlier. And you're going to put the data that I listed up here all in here, and we are going to have a HA that is going to be a less than, sorry. All right, now the less than, remember, is because we have mu1 less than mu2. And ours, it says, remember, it says greater, that we have more food, but that's because it's large greater than small. But remember, my large is over sit here, so that means it's going to be the small is less than. All right, and then you'll conclude, because we have a p-value, a very small p-value, and p low, reject ho. And then you're going to say, since I am rejecting ho, then that means I'm going with ha. So yes, we do have convincing evidence. Since we rejected ho, that would be a type 1 error if I made an error. I didn't necessarily make an error, but if I made an error, a type 1 error, remember, is rejecting ho when I should not have rejected ho. And that would be a type 1 error. All right, I hope that helped. If you have any other questions, let me know.